All right, so find the area of the largest rectangle that can be inscribed in a semicircle of radius r. Okay, so there's a lot of questions that are along these lines as well, where you're inscribing one shape in another. Sometimes they're two-dimensional shapes, sometimes they're three-dimensional shapes. And I think there's a few of those on the worksheet that I gave you yesterday. I think one of them has like a cone inscribed in a sphere, and another one has a cylinder inscribed in a sphere or something like that. Okay, so there's these questions about inscribing one thing inside another. Okay, and in this case we're trying, because we're looking in this scenario about two-dimensional shapes, we're trying to maximize area. If we were looking at three-dimensional shapes, we'd probably try to maximize volume. Okay, so what we are going to need to do to start is let's draw this. Okay, so I'm going to draw a semicircle. Ooh, let's change the thickness. Okay, and we're told that the radius of this thing is r. It has a radius of r. We don't know what that radius is, but the radius is set as r. So we need to take this and treat that as a constant. Okay. Now what we're going to try and do here is inscribe a rectangle inside of it. So there's our rectangle. Okay, and there's lots of ways to do that. Right, so here's another example that I just drew off to the side. If you're watching the video, I suppose this isn't going to make sense. Maybe I'll do it over here. You could also do it like this, I suppose. That's another rectangle that's inscribed in a semicircle. But we want to do it in such a way that we maximize the area. Okay, so this is not maximizing the area. I'm going to erase that one so we can just kind of get a visual sense of what this is going to look like. Okay, now, the area of a rectangle, how do we get the area of a rectangle? Length times width. So maybe what I'll do is I'll put in the length, I'll put in the width, because the area of this thing is length times width. Okay? And the other piece of information that we know, and although we don't know what it is, we can treat it as a constant. We can treat it as if it was a number, is the radius. Okay? Now the radius doesn't really show up as the length, and it doesn't really show up as the width of this rectangle. However, yes? Would it be the hypotenuse? Yeah, it's like this diagonal from sort of the center, not the diagonal of the entire rectangle, but it's the diagonal from the center of the length to a corner, exactly. So you want to draw that in there somewhere. So this is now the radius. And this we can treat as something that will never change. It is not a variable. And that's really good. Okay. Now this little piece, now this very nicely makes a right triangle. That's great. Okay. This little piece, let's say I called that x. That is not the length, but it's related to the length. What's the relationship between x and the length? Half the length, or length is 2 x's, right? So let's say we want to express area in terms of x. Now we have a way to express length in terms of x. That's good. Can we express the width in terms of x? And how would we do that? How could we get an expression for the width using the variable x? Yeah?
Wouldn't it be like x squared plus w squared is equal to r squared?
Exactly, Pythagorean Theorem. Yeah. So we can take this and sub that in there. If we also want to use the variable x for width, we need to use the Pythagorean Theorem. Okay, so we're going to get x squared plus w squared equals r squared, which means that w squared equals r squared minus x squared, which means that w equals, it should be plus or minus r squared minus x squared, but because this is a width, width has to be positive. It's just the positive square root. So now we can take this and sub it in there. And now we have an equation for area that only uses two variables, a and x. Okay, so our area, which is what we want to maximize, is equal to 2x, which is the expression for the length, times the square root of r squared minus x squared, which is the expression for the width. And now we have something to maximize, because we can take the derivative of this, right? And that's because we know that r squared is a constant. Right? We don't know what it is, but it could be 5. It could be 5 squared. Okay? All right, so this is what we want to maximize. All right. So to do that, we have to take the derivative. Now I'm going to rewrite this as 2x times r squared minus x squared to the 1/2, because to take the derivative of this, I need to do a product rule. Right? So my u is going to be 2x. My u prime is 2. And then my v is r squared minus x squared to the 1/2. So my v prime is 1/2 times r squared minus x squared to the negative 1/2. And then I have to use the chain rule, take the derivative of whatever's inside here, which is negative 2x. Okay? Now what I'm going to do, and some of you guys on your derivatives test, this may have actually helped you out a little bit, is before I plug this into the product rule, I'm actually going to simplify v prime. Okay, so I'm going to clean this up a little bit. So for example, I can cancel the 2's. Okay, and then in the numerator, I'm going to have negative x. And then this has a negative exponent, so I'm going to bring it down to the denominator. Yes?
Why isn't it like 2r minus 2x? Why is it just minus?
Oh, because remember that r is treated as a constant. So this would be like a number. Does that make sense? Okay, good question. And then this is going to come down. So r squared minus x squared to the 1/2. Okay? Now I have all of my pieces, so I can plug this all into the product rule and take the derivative. So a prime is going to be u prime v, so 2 times r squared minus x squared to the 1/2 plus uv prime 2x times this. Maybe I'll just do this. Okay, and my goal is to figure out where is this equal to 0. And in order to do that, I need to simplify a little bit. So what I'm going to do is I'm going to get a common denominator between the two terms. Right now, this is over 1. The denominator to this is r squared minus x squared to the 1/2. So I'm going to multiply this first term by r squared minus x squared to the 1/2 over r squared minus x squared to the 1/2. And then I'll have a common denominator. And what ends up happening is that the exponent here is now 1, which is quite nice. So I end up with 2 times r squared minus x squared. And then plus 2x times negative x is minus 2x squared over r squared minus x squared to the 1/2. And that is a prime. Okay. And if I simplify a little bit more, scroll down a little bit. Okay, I have to distribute this in, then collect like terms. So I'm going to get 2r squared, and then minus 2x squared minus another 2x squared. So altogether, that would be minus 4x squared over r squared minus x squared to the 1/2. And that is a prime. Okay. Now, yes.
Next, you need like the critical number, right?
Yes.
I was gonna ask.
Yes.
Can you kind of like factor it by 2 and then just do like 2
Yep.
squared minus 2x squared?
You can factor it. So if you factor out the 2 to get the critical numbers, you absolutely can. You don't have to, but you can. Okay, so to get your critical numbers, right, you have to solve this. 2r squared minus 4x squared equals 0. Okay. So yeah, you can factor out a 2 if you want, right? Or you could also just divide both sides by 2. That's probably the easiest thing to do. Because if you divide this by 2 and divide that by 2, 0 divided by 2 is still 0. So sure, let's do that. Then you're just going to have r squared minus 2x squared equals 0. Okay? And if I keep going, I'm going to have r squared equals 2x squared. Remember, r is a number. We don't know what it is, but it's a number. It's a constant. And I want to solve for x, so I'm going to divide by 2, divide by 2. So I get x squared equals r squared over 2. So I have to take the square root. Okay, and remember, usually, if we were just solving this, it wasn't attached to a context, then I'd have to take plus or minus the square root. But because we know that x represents, if you go back to the picture, well, we don't even have to go back to the picture. X is half the length, right? So it must be positive. So it's only going to be the positive square root of r squared over 2, which is r over the square root of 2. That's the critical number. Okay? Now, I do want to talk about the critical number here, because it is kind of significant. Okay? So if you look at the critical number from here, you get r squared minus x squared equals 0, which basically means that r has to equal x. Right? You're going to get r squared equals x squared, r equals x. Okay? Let's go back to the picture for a second. Okay? if r equals x, if this was equal to x, okay, what would the width be? Right? If x was way out here, think about what the width would be. 0. Then what would the area be? 0. So that critical number actually corresponds to the minimum area, not the maximum area. Okay? So this will give you an area of 0, which is the minimum area. Okay, so I do just want to bring that up because when you're solving these problems and you get these critical values, you will get both the max and the min. Okay, so you got to say, okay, well, which one am I after? This one's going to give us the max, though. So once we get that critical number, we got to go back to our area function. Right? Our area function was 2x times the square root of, what was it, r squared minus x squared. Right? That was what area was. The maximum area occurs when x equals r over the square root of 2. So if we want to know, well, what is that? We have to plug in r over the square root of 2 for x. So when x equals r over the square root of 2, area is going to equal 2 times r over the square root of 2 times r squared minus r over root 2 squared. Okay, so I'm plugging in the value r over root 2 for x. And now I got to simplify that. Okay, so there's not much we can do here on the outside of the radical. This is just 2r over root 2. But let's see what we can do on the inside. This is going to be r squared minus, if I distribute this in the numerator, I'm going to have r squared. And in the denominator, root 2 times root 2 is 2. And r squared minus r squared over 2, or r squared minus a half r squared, this becomes a half r squared. Half r squared or r squared over 2. Okay, now, when I simplify that, if I take the square root of r squared, in the numerator, I'm going to get r. In the denominator, I'm going to have root 2. Okay? And so let's see what we have here. This becomes, in the numerator, 2r times r is 2r squared. In the denominator, I have root 2 times root 2, which is what? 2. And then these cancel. So my maximum area is r squared. Okay, that's tricky. Oftentimes, you'll get a similar type of problem, but you'll be given like, okay, the radius is like 6. So you'll have an actual number to work with. Okay? All right, any questions with that? No. Okay, so I'm going to stop there.